Welcome to the Yorkshire Full Stack. Sorry. People have come from all over the globe. That's really great. But we are mostly kind of focused on in Yorkshire as far as the community is concerned, but we will carry on doing these events online so that we can get people from further afield and get people involved in these full stack conversations, which are always really interesting and fun. This is our 5th event. We have it every 2 months on a Thursday, so please do come back. We welcome any ideas or topics or anybody that would like to do any talks or on anything interesting in the full stack space. It is rather nice weather today, so we might not have quite as many attendees as we had hoped, but yeah, thank you everyone that has made it. This will be a really fun and exciting talk. So we talk about full stack, latest techniques, trends, and architecture. Thank you to my other co-hosts. Without you, it wouldn't be possible. Thanks to Kev and to Sean. Kev works at Evolution, Sean at the Very Group, and I work at BGSS. Most people are hiring these days. We're all hiring these days. If you're interested in anything like that, then just come and chat to us. But this is not really a hiring thing, so we're not talking about that anymore. This is an inclusive space. We welcome you wherever you're from. We welcome you regardless of your race, religion, looks, gender identity, sexuality, or knowledge of tech. This is very much a safe place. We welcome silly questions that maybe other people totally know. We are just welcome to join in and be part of this community wherever you're at. So please do treat other people with respect and as you would like to be treated. What's really exciting is our next event will actually, hopefully, be our first hybrid event. So this is our 5th meeting, but we've never actually met in person. So on Thursday, September the 22nd at 5:30, we will be having the hybrid session at the BGSS Leeds office, which is dead close to the station at Whitehall Quay. Please do come along in person if you feel comfortable doing so. If not, we'll be streaming as usual. As for a topic, there's a few topics I'm thinking of and we've been discussing. If you've got any other ideas, please do let us know. Some of those ideas are, is it time now to finally learn Golang? What are some of the latest CSS techniques? Maybe some of us have got a bit out of touch with that. And then also another topic, which maybe Luca might touch on a tiny bit, is monorepos. But the reason that you're all here is to hear this fine gentleman speak with us. So I've known Luca for a number of years now, worked together at DAZN. Some may know him for his great work on micro-frontends. He's written a book on it. Have you got just one book out, or have you got a couple of books out, Luca?
I have one on reactive front-end architectures with A-Press, and this one that is coming in October on micro-frontends for O'Reilly.
Yep, brilliant, good stuff. So we're looking forward to that. Yes, he also runs the JS community in London as well. So very much involved in the community and is now Principal Solutions Architect at AWS. So welcome, really good to have you here. We'll just hand the floor over to Luca. As I said, any questions, please do ask in the Q&A, and just for general banter and conversation, please do chat away in the chat. Hopefully in probably about 35, 40 minutes in, we'll open up the floor to those questions and maybe have a bit of interaction and discussion with Luca, if that sounds good. Okay, thank you. Over to you, Luca.
Thank you a lot. And meanwhile, I'm setting up and sharing my screen. We have a big guest here in the audience. I see there is Zack Jackson. Zack is the brain behind Module Federation. So if you want to ask something, ask him more than me. Let me know when you can see it.
Yep, can see the screen.
Fantastic. Yeah, oh, thank you very much for having me. It's a pleasure being here. As Rich knows, I'm a big fan of communities, and when I can, I'm always trying to be useful for the community. So today we are going to talk about Module Federation. It is a plugin that was created recently. I think it was last autumn when Zack delivered it together and alongside with Webpack 5. But we are talking about that also on how to use it with micro-frontends. So who am I? My name is Luca. I'm a principal solution architect at AWS. I'm an international speaker and an O'Reilly author. Feel free to reach me out anytime. Also, if you have other questions that I cannot answer today, I'm more than happy to answer in the next days or next few hours. Not a problem at all. So let's start with the definition of micro-frontends, because I think it's very important to identify what they are, so we can then deep dive into how to implement them with Module Federation. So in my opinion, micro-frontends are a technical representation of a business subdomain, and they allow independent implementation with same or different technology, and they should minimize the code share, and finally, they should be owned by a single team. So as you can see from this definition, I have highlighted a few key parts, and let's deep dive in every single of them. So technical representation of business subdomain is coming from domain-driven design. If you are familiar with that, domain-driven design takes a domain, so it could be, let's say, a large project, and divide these multiple subdomains, having always an eye from a business perspective, or as I prefer to say, from a user perspective. Very often we think how to slice our application that are comfortable for developers, but in reality, we should look on the other way. So we should always look from a business perspective. The other thing is that we want to create independent implementation. What does it mean is we want to create artifacts that can be deployed independently. So we don't have to coordinate with other teams. One of the things that is really frustrating when I was developer, but I think it didn't change too much recently, is that when you have to coordinate and you start to have external dependencies, can be painful. And what we are trying to do here is trying to optimize for speed and independence and create teams that are autonomous, and they can take their own decision and take the right path for their business subdomain. We want also to create, with micro-frontends, we want to use same or different technology. Now, one thing that I heard several times is that micro-frontends are great if you want to mix and match different UI framework. Unfortunately, the same best practices that you have with single-page application or server-side rendering one are valid for micro-frontends. Therefore, despite you can, and technically you could do that also with a single-page application, for instance, it doesn't mean that you have to. And therefore, for me, there is a specific moment in the life cycle of a project where micro-frontends make sense with different technology choices. That usually is when you are porting from a legacy application towards a micro-frontend architecture. And in that case, yes, I see that there is value on having two different UI framework or the same UI framework with different versions, mainly because you can really start to generate value for your customers, deploying one micro-frontend in production, see how it goes, or a bunch of micro-frontends in production, see how it goes, retrieve real feedback and real data from the users, and then slowly but steady apply the strangler pattern that basically would allow us to kill the previous legacy system and then have a brand new application up running. The other things that is sometimes controversial, and I know that, is minimize the code share. I know that as a developers, one of the most interesting and challenging part is creating abstractions, and abstractions are great. But in distributed system, having multiple abstraction and start to reuse them across a system can be complicated. Mainly because when you talk about distributed systems, sometimes and more often than not are, especially nowadays with these, let's say, remote work that started to finally being used extensively by customers and sorry, by companies, and it means that you have people that are spread across the world, potentially at different time zones and wherever. So having the possibility to be encapsulated and having your own wheel inside your micro-frontend is definitely the preference. Obviously, that doesn't mean you shouldn't share any code. You should share code, but making sure that is a meaningful share. So if you have, for instance, a very complex part of your application, like a specific complexity around the component, think about the payment, for instance, or I don't know, you have a very complex video player that you need to handle. Yeah, that makes sense. Also, a design system is a good example where sharing code makes a lot of sense. But sometimes, you know, you start to abstract libraries and everything, and when you have too many of them, you create design coupling between your teams, and this is exactly the opposite of what you should do in a distributed system. And then we talk about ownership, because often we think, okay, I'm creating my micro-frontend and I do everything, but then I can hand over to someone else. In reality, the ownership part is important. I really think that the DevOps model, where you build it, you own it, you run it, is the way to go. And that is not only for infrastructure or for the backend part, but also for micro-frontends. That means that potentially you can have multiple teams that can contribute to a micro-frontend, but the one that is owning the micro-frontend, therefore is responsible for what is going into production, should be the last team that can say, yes, this code, we want to maintain this code and is going to production, or not. So because of that, a few years ago, I had to figure out how to structure a micro-frontends architecture. And one thing that really helped me is trying to define a mental model that then I reused in doing some let's say, discussion with other teams in other contexts. And it helped me a lot during my journey into this architecture style. I called it the decision framework, and basically is a mental model that is composed by 4 pillars. So the first one is you need to define what a micro-frontend is, and you can have like what they call vertical split, where you have one micro-frontend loaded per time, or horizontal split when you have multiple micro-frontends in the same view. Then you need to define how you want to compose them. You want to compose them at client side, edge side, or server side. And the same for routing, how you're going to move from one route to another one. And finally, how you're going to communicate between micro-frontends. Either you pick vertical or horizontal split, you need to communicate between micro-frontends. Sometimes when you have micro-frontends in the same view, so you have an horizontal split, you need to communicate and maintain decouple those systems. And at the same time, when you have like one micro-frontend loaded per time, you need maybe to share a JWT token across the entire application. So all these things has to be taken into consideration if you want upfront. That doesn't mean that you need to define everything upfront. I'm a big fan of lean development and lean architecture. Therefore, you try to take the decision at the most responsible moment. However, those 4 pillars, when you define them and you are sure that you are making the decision that fits for your projects, then you can cascade all the other decisions using those pillars for guiding you towards the right path. Either that how you can implement the design system, how you want to use your version of control strategy, how you want to manage the observability. All of those decisions will cascade based on those 4 that you can see here in this slide. And we are going to use today those 4 pillars in order to see how those can be applied on an application that is a demo I prepare based on module federation. So first of all, I think everyone here is familiar with Webpack, that is a JavaScript module bundler that is, let's say nowadays is becoming even more, because thanks to the plugin ecosystem that is available for Webpack, we can do way more. We can manipulate HTML, we can manipulate CSS, we can do way more. And one of the great things with Webpack 5 is the introduction of module federation. That is a plugin that allows to dynamically run code from another application. And in my opinion, is let's say great, because Zack did an amazing job for not only solving some challenges that were afflicting micro-frontends architecture back in the days, but also he plugged himself in an ecosystem that makes the life and the developer experience of developers very sleek. And that for me is always a +1 on these things, because we are thinking not only on how to solve technical problems, but how to create also a sleek experience that is not always that trivial. So one thing Module Federation does, imagine like as you can see in this diagram, we have multiple micro-frontends that can be developed by the same or multiple teams. And then with Module Federation, you can just say, okay, I want to share some dependencies. That is one of the problems you have with micro-frontends, how multiple independent application can share, I don't know, the same UI framework, React, Vue, Angular, you name it. And you want also to share the same version of the framework and maybe other libraries. And one thing that Webpack does very well is that you can define what you want to share, and then Webpack basically with Module Federation is going to create the different chunks. But then when it's time to load them, it is going to load only once those shared dependencies. So in the case of this, let's say implementation, when I load the catalog micro-frontend, and they have the chunk 14 and 33 that represent my shared libraries and shared dependencies, I will load just once. So the next time I don't download again the same code. That is absolutely great, because if you think in another way how to do that, it depends which technique you're going to use for building micro-frontends, but it could be that you need to think about this scenario by your own. But moreover, Module Federation allows you to encapsulate the scope of your library. So therefore, if you want to use the same library with different versions, and it will take care about isolating the scope about those. That is another great functionality of Module Federation. Moreover, if you're familiar with Webpack, you don't have to change the way how you are building your project. You just have an additional feature that is available for you. And finally, one thing that I want to highlight, Module Federation, it won't be anymore only on Webpack 5. It's already available with limited functionalities on Webpack 4 and Rollup, but also it was announced recently that ES-Build will take the specs of Module Federation, and they are going to build that. So we are seeing really an inception of Module Federation and the thought behind that in multiple building systems. That is great in my opinion. So let's try to understand the anatomy of how to set up a Module Federation. There are two key concepts that we need to understand with this plugin. You can have either a remote, and therefore you have an application that is loaded inside a container, and the container is called host. Those are the two key things. So let's see the anatomy of a configuration for a remote. So in this case, what you have is assigning remote, as they call it, the name of the My micro-frontend. You define the file name that basically is a description of what you're going to load, and you define all the exposes, let's say, module that you want to do. Obviously, bear in mind, Module Federation is not only for micro-frontends, it can be used also for other libraries, or even for a design system. If you want to say, I want to expose every single part of my design system, I can do that. The other thing that is interesting, oh, sorry, I forgot to do this. The other part that is interesting is to define shared dependencies. And therefore, there you can start to say, okay, all my project is using React. And therefore, in my remote, I'm going to say, I want to use React. And also, I want to define that React is loaded just once. And that's what singleton does, basically, behind the scene. So you load only once the dependency. This is a way how I obviously, inside those APIs that are the advanced API of Module Federation, I can do even more. I can also say I want consume this synchronously and not asynchronously, like you can see in this example. When you move to synchronously, obviously, Webpack has to bundle differently your code, and therefore you are going to have an upfront download of the dependency that is bigger. That usually is not, let's say, the best way of handling the bandwidth for your users. So therefore, one of the suggestions is always handling asynchronously those things. But you can also specify a version of your library. So potentially you can say, I want to use React 17 and the specific version up to the using some ver like any npm package. When we go to, instead of host, what you have instead here is you define all the remotes. The interesting part here is that you can have a list of remotes to load. And as you can see, it's very simple. You have an ID, then you have a head sign, and specify where you want to find that. That could be either a localhost or it could be spread across the internet, and it won't be a problem as long as you describe what is the exact let's say URL for to find the remote entry. That was the file that is describing basically where to find all the different chunks of your application. Again, here also in the host, you need to specify what you want to share, and that is very key. So every time you want to share stuff, you need to share, you need to define those information across all the configuration. So module federation in this case, as you can see, is inside a normal Webpack configuration, and you just add in this plugin the information that are needed for deploying your application and allowing module federation doing the magic behind the scene. So what we are going to see today is this example here. I try to simplify with this diagram. So we have an application shell that usually in the micro-frontends vocabulary is an application that is running at the beginning for the when the user is selecting a specific URL and is staying there for the entire session of the user. That means basically the application shell will not fade away, will always be there, and is responsible for loading, in this case, multiple micro-frontends. Usually my suggestion on when you design an application shell is trying to avoid to pollute the application shell code with specific domain logic. Therefore, encapsulation inside the micro-frontend is the favorite route of what we are going to do. So in this case, as you can see, we have on the first part a sign-in micro-frontend that is a micro-frontend that is owning the sign-in strategy for this application. Then we are going to have a catalog and catalog details. So in this case, we are going to see how we can integrate a local routing inside our micro-frontend. So imagine that you have a team dedicated on the catalog, and this team wants to have multiple views. That is pretty normal, right? And in that case, you can own the entire experience, and we want to see how, let's say, we can integrate local routing. So in this case, how to do routing. Application shell is responsible for the global routing, so the possibility to jump from sign in to catalog to my account in this case, and instead you can also implement a local route. Finally, I want to show you another example that is basically having multiple micro-frontends in the same view. So this is the example where you have multiple teams that are working on the same view, how the micro-frontends can maintain their boundaries and communicate together. We are going to see the communication between multiple micro-frontends. So in this way, as you can see, we are covering horizontal and vertical split. We are going to cover the communication between micro-frontends between different views and in the same view in the case of my account. Finally, we also see how we are going to handle the routing across multiple views and the internal routing in the case of the catalog. So we are covering basically all the different things that are composing the decisions framework. So this is the demo that I prepare. Okay, so as you can see, I have gadget shop and I can add my username and password. So this is the micro-frontends for the sign-in. I'm loading now the other micro-frontend with the catalog. I can select an element. I go through the local routing where I see the details of the shop. I go back to the shop. I can go to my account. Bear in mind what you see on the left and what you see on the top is inside the application shell. So now I have two micro-frontends, the account details and payment details. And when I click change payment method, I will change that string there that I'm highlighting now. And this is a communication that maintain the boundaries of the two micro-frontends. I can also retrieve the token if I'm authenticated from anywhere in the application. And I can also sign out a user and show a different look and feel, different UI in the case of my account if the user is not authenticated. So in this case, I'm deleting the JWT token that I have in my session storage. and I go back to sign in. So say go back here and I go to my account. As you can see, I have a different UI. And that's basically what we are going to discuss today. This is the example that is covering different things. On top of that, as you can see, I used Material UI. Material UI is in this case for me, my design system that I'm using for this application that is spread across the entire application. And I make sure that there aren't any clash between styles that are added inside the application. Okay, so let's start with the folder structure. I take screenshot of everything that let's say I'm going to talk, so we can focus on the key topic. But if later on you have some questions, I also have the code base behind the slides. So if you want to discuss that, not a problem. So in this case, a folder structure is composed by multiple applications. Here, for me, because I was the only developer creating this, I created a mono repo with all the different applications. But as you can see here, every single file represents a standalone application, and any single folder represents a standalone application. If you take sign in, for instance, we are going to have a basic structure. So we have the distribution folder, node modules, source folder, package.json, and webpack config. Git ignore as well, obviously. The interesting part is obviously you can do with monorepo, you can do with multiple repos. It depends really what you need to optimize for. There isn't right or wrong. If you want monorepo, you optimize for maintaining the dependencies across micro-frontends, always up to date, and therefore everyone has to deal with the latest and most updated version. That's basically one of the benefits that you have with monorepo. Also, the discoverability of your code became easier, because in reality, if I am a new joiner and I want to see how someone else implemented the specific pattern, I just go in my repo and select someone else, some other teams that have done that. If you want to work with more isolated, let's say, repositories, and then work with APIs, a contract, that is another way that you can do that. You can work with polyrepo, but you're optimizing for something different. So you have, let's say, a lot of small repository that probably will build very quickly, and you simplify a bit the dealing with CI/CD, because if you think about that, vast majority of the tools out there are definitely let's say, available for handling these small repositories, and you don't have to invest too much on the CI/CD part, because probably what is available out there will be fine. Instead, with the monorepo, potentially, when you start to have the project growing, it can, you maybe start to create some internal tools in order to simplify the life of developers. So it depends really what you have to do. I don't have, let's say, a preference. It depends what you need to optimize for. And that's why, in this case, for me, was jumping from one place to another one very quickly. And therefore, I selected monorepo, but also polyrepo is absolutely a good decision. So when we go to the application shell, that again is the part that will always be there. As you can see here, what I have is I define my module federation plugin with the name. I define all my remotes, that in this case are the free micro-frontends that I have, my account, catalog, and sign in. The interesting part here is that all of them are running locally, but with different ports. That means potentially I can have a different entry for any of these micro-frontends. So potentially when you run, you are responsible, for instance, of the catalog micro-frontend, you want to do an end-to-end testing and seeing how the user will behave when is signing in and then going to my account through the catalog. You can mimic that and maybe change, instead of using and build all the different different micro-frontends in the same locally, you can do pointing to a specific endpoint on staging environment or testing environment. It's completely up to you how to set up that. And this became very easily because potentially recently Zack released a possibility also to remote load dynamically your remotes and not defining inside your module federation plugin, and therefore you can create your logic. If you want to instead doing that in a more, let's say, using Webpack, potentially you can apply, there is, I think, if I remember well, it's called the define plugin that will allow you to create some logic inside your Webpack plugin for change some parts of your application based on where you're running your application. Potentially you can say in development, these are the base path of my remotes. In staging, this is the other base path. In production is another one. So potentially you have a lot of possibilities to change that in a way to make very comfortable your developer experience. But those are the possibilities currently you have with Webpack in general. Then the other thing that we have here is all the shared libraries that I want to have. So I want to have React, React DOM, React Router, Material UI, and core and icons that are bundled together and are loaded just once. Obviously, this is only the configuration of Module Federation. So potentially you can mix and match those configuration with the ones that you have in Webpack. I can show you if you want later on other possibilities. So if you don't like the way how Module Federation is splitting the chunks, you can reduce the amount of chunks just defining that inside Webpack. You can also decide that instead of numbers, you want to have names, and potentially you can do that because those are possibilities that are out of the box with Webpack. So when we look at the application shell, the things that are very important are basically these three blocks of code. The first one is how we are going to load our micro-frontends. In the case that in my project, I use React. I'm using React Lazy for lazy loading a specific module. In this case, my micro-frontend catalog sign in and my account. And when I want to render that, I'm using React Suspense. Up to now, React 17, we have Suspense that is part of the experimental APIs. But in React 18, considering it was successfully implemented in the current implementation of Facebook, they are going to add Suspense as an API that is available to everyone and not experimental mode anymore. What Suspense does is basically allowing to signal to the React virtual DOM that the DOM is not complete yet, and you can replace for now with a fallback that could be as simple as a string, like you see here, I have loading, but it could be as complex as a component. And they are basically inside the renderer MFE function, you just pass what you want to load. So in this case, when as you can see, I have my React router and I use switch. And when I go to my account, or when I go to shop, or when I go to the root of my application, I load a different micro-frontend. Now, the one thing that when you think about the global routing, therefore the routing that is at the first level handled by the application shell, my suggestion is never go after one level of the route. So mysite.com/something. Never go down the route of let's say, at the application shell level, going more in depth about these levels, because that should be deferred to every micro-frontend, as we are going to see in the catalog example. So those are the three simple things that you can see are nothing, let's say, specific to micro-frontends, but you can do that also without using Module Federation potentially. But those are the way how we can do that with in this example. Now, another important thing is when you use Material UI, you need to figure out a way but that is for Material UI or any other, let's say, implementation or micro-frontends that you're going to implement. And one trick for making sure that your CSS style are not going to clash inside the same view is using a prefix. Extremely simple, but basically solving the problem elegantly. So in this case, with Material UI, you can use create generate class name, where you can pass a seed that basically is your prefix for prefixing every single style CSS class that you have. And that is simple but effective, and it's something that you can do with any other system. There are tons of plugins that allows you to do this, but it's something that you need to bear in mind because it's very important. Otherwise, you risk that you have some CSS that are overriding others, and it's not very pleasant for the user as well as for you for debugging that. The other thing that we need to discuss about is how to define a remote. So I'm going to discuss sign-in as a remote. All the other remotes have exactly the same logic and configuration, nothing changed. And in this case, what we have is a name of my micro-frontend sign in. We define the remote entry, and then I have all the expose. So in this case, just one that is the entry point of my micro-frontend that is signing. And then I shared all the things that I need to share. So in this case, my libraries, again, core, styles, DOM, and all the others. In the sign-in micro-frontend, the interesting part is how we communicate between views, so between micro-frontends. So in that case, what we do is when you have, for instance, a token or you have something that has to be shared across multiple micro-frontends that are not in the same view, a recommendation is using a persistent token like web storage, so session or local storage, or cookies for what is really meaningful. So in this case, the token. And when you have something that is more volatile, you can use query strings. And that is a super valid, let's say, possibility, but obviously you need to understand when to use one, when to use the other one. I highly discourage, obviously, to use query string for sessions or anything else. But if you have, for instance, you have a micro-frontend that collects a lot of elements, and someone maybe is an e-commerce, and someone is selecting an element and goes to the detail page, maybe the detail view is handled by another team. So in that case, you can pass which is the element selected through the query string. So you just pass the ID, and then every micro-frontend inside that view can retrieve the ID and use that for consumed APIs, and then use obviously the token that is available on the local storage or session storage for consuming the API that are for an authenticated area. So again, those are usually the practices that I've seen working very well when we talk about micro-frontends. Then when we go to the catalog, I want to show you just one thing. So inside the source folder, you have multiple stuff that are basically multiple views of the same micro-frontend or components, like in the case of product JS, that is a component that we use for rendering the element. So in the catalog, what I describe, the entry point will have basically this routing, again, React router. And in this case, I'm going to take what is the first level of the URL. And this case will be shop, because the global routing is saying load the catalog in when a user goes to /shop, and it's taking that with a $path and directly from the user route match hook that is available for React router, and then it's going to /product ID in the case of the details, or remain inside the /shop in the case of the home component. What you have here that is extremely simple is when you go to the details page, you can have like you can retrieve the query string, as I said before, for understanding which API to call and which parameter and data to retrieve from directly from my API. So in this case, I can retrieve the product ID that is available inside the URL and then use that for fetching the data for a specific product. The other thing that we need to discuss is my account. And my account is, let's say, a host inside a host. Yes, you can have this kind of combination. So you can basically create a multiple hosts, and potentially you can do even more. And as Zack is like to say, you can be bi-directional. So you can have a remote that is exposing some data and to a host and vice versa. Now, my suggestion, based on the experience, is that it's better that you go in unidirectional flow when you start to share stuff. And maybe Zack can disagree on this, but I believe that is like we have done in the past with other architectures, where you have, let's say, bi-directional communication, debugging becomes challenging. Instead, if you go with a unidirectional flow, like it was implemented in this case back in the days with Flux, and then later on with all the state management, we saw that the developing and understanding where a problem is, it became extremely easy. So I would suggest, despite it's possible, to maintain this unidirectional flow for micro-frontends, and never share something with the parent micro-frontend. So in this case, with the host. So if you have a remote that want to communicate with the parent, always use something for decoupling that, and we are going to see that in a moment. In this case, we have a my account that is again a host inside a host, and is loading two remotes. We have to load the account details and payment details. There are two other micro-frontends. All the rest is exactly the same, nothing is changed. And when we go on the implementation side, what we're going to see is that if you are authenticated, I create an event emitter. I use this library but there are many libraries that you can use for creating an event emitter. And what you do is you inject the instance of the event emitter inside your authenticated view. That is, we will see in a moment, a view that is composing the two micro-frontends together. If you don't have the token, you are going to show a different view. So in this case, obviously you can go as wide as you want on the checks for security checks, for making sure that the user has a token, is a valid token. You can call maybe a refresh access token if you want, in order to make sure that the user is really entitled to watch specific authenticated area. So it's completely up to you how you want to handle that. For the simplicity of the example, I wanted to share this implementation. So in the case of the authenticated view, we are using same thing that we have done for the application shell. So we lazy load our two micro-frontends with React Lazy, and then we use React Suspense for showing and composing my view. So in this case, I have account details and payment details, and I inject my emitter inside all of them, both of those micro-frontends. Why that? Because in this case, I don't have to share anything between the two. The problem I see when you are one maybe thing that is becoming normal for the first time that you implement micro-frontends is that you think about creating global state. The problem with global state is, by design, you are coupling teams. So every time that someone is updating the shared state, then you need to make sure that other teams are not doing something similar, or their application is working. And when you have, let's say, two teams in the same working the same view, it could work. When you have maybe 5 or 6, it can be a nightmare. And therefore, if you instead, considering that you should minimize the, if you slice correctly your micro-frontend, you should minimize the input and output of your micro-frontends. The best way to handle that is through events, or a pub-sub pattern that will basically allow you to decouple the micro-frontends in the same view, and allow anyway a communication that is, let's say, based on events. And in this case, could be event emitter, custom events that are available in JavaScript out of the box. You can use an observable if you're a fan of reactive programming, and you can use even signals library if you want. But there are, let's say, a variety of solutions for implementing the pub-sub pattern on the front end. Just pick the one that you feel more comfortable with. So what you do with when you have an emitter is that when I click a button, like in this case, I have the on payment changed, I'm just emitting an event. What it means, I can define a string that they represent my event, and I can pass also a payload. In this case, it's a string, but can be as complex as you want, an object or whatever. The suggestion that I have personally is not using strings, but creating, let's say, some value object where you list in constant all the different options for a specific micro-frontend, and that is basically your contract between different micro-frontends. If tomorrow we want to add a third micro-frontend that has to react to this payment change, I don't have to coordinate with the team responsible for payment details. I know what is the output, I know what is the input of this micro-frontend, and the only thing that I have to do is listening to that payment change event and act inside my boundary. So that create, let's say, some nice isolation, not only from a technical point of view, but also, and more importantly, sometimes on the organizational point of view. So in this case, what I have is the other account details micro-frontend that is listening to this payment change. When that happens, I'm going to change the payment method. And in this case, you're going to have the update of your UI, like you have seen in the video. And that's basically how you're going to communicate. Once again, try to keep that, try to don't leak the domain outside the micro-frontend, trying to keep it, let's say, inside the boundaries, because that will allow you to have let's say, your own decision on how, and also you own the future in your hands when you want to move forward. So in summary, we have seen how the decision framework works inside this application. We have seen how to apply a design system in a very simple way. Obviously, it was the example on purpose was simple, just to explain the different key part that you need to focus. You know how to define a micro-frontend. It could be one per view or multiple per views. It's completely up to you. It depends what we're optimizing for. Bear in mind, in architecture, there isn't right or wrong. It's only the right solution for your context that is based on the trade-off that you identify for your specific solution. The other things that we have seen is also how micro-frontends are communicating together and how you're going to route. And those are the different things that we have seen so far. That's it for me. Hope we have enough time, I think so, on discussing a few things. And if you have any questions, that is my email. Feel free to reach me out anytime. I now switch to the other view so I don't share the screen, but at least I can see what the questions that are coming up. Thank you very much.
That was absolutely incredible. Thank you so much. My mind is blown. I'm kind of trying to replay some of those kind of explanations in my mind, and I think I might even need to go back and rewatch the video to try and make sure I'm kind of up on everything. But yeah, I think we can see some of the possibilities and some of the kind of ways this is made doing micro front ends a lot more flexible and doable. I've recently done a micro front end project with a government client, and server-side rendering is so difficult. It's just so flipping difficult, and I think this might uncrack some of those real challenges that we, because basically we were looking at just hand rolling our own server-side implementation to make that work, but I think we can see that it will work really well with this. But anyway, a lot of you have been asking questions, so thank you very much. Dean S has particularly been asking quite a few questions, and we also invite Zack to add some comments in a few minutes as well. So SSR and module federation, should I async scripts the chunk for optimization?
I think Zack can answer even better than me. I know that he's working on something here with Next.js. I was following him and his progress, and I think he released something yesterday, actually, or 2 days ago, or something this week that he released around that. I think we need to, there were some challenges on, okay, we have Zack, perfect. So Zack, you can explain even better than me what are the challenges currently on server-side rendering, because I know that you had, you scratched your head a couple of times.
Yeah, sorry, I just had to hop out and hop back into the Zoom to join in as a panelist here. So I think it was around server-side rendering.
Yes, correct. So the question is, if when I have server-side rendering and module federation, should I async scripts the chunks for optimization? But I think so server-side rendering, you had quite a few challenges recently.
Yeah, so server-side rendering, there's two ways that you can go about doing it. There's two federation mechanisms that you can use. So the one mechanism is code streaming. So that's pretty much, and that's kind of like I posted in that chat, this project called micro-lib that we built, which is a hexagonal architecture. What it essentially does is it reads the code over the network. So we tell Webpack that the file system, it's not fs read file, it's fetch, or it's s3 get bucket. And then we can stream the code into whatever process that we need. The problem is once it's in the require cache, it's very hard to pull down the updated chunks. As your remote gets updated, it gets stuck. So what I've been working on, what we just cracked, I actually have it running in the background here if anybody wants me to share the screen, is it's super basic, but it's server-side rendering using normal fetch inside of Next.js. So rather than code streaming and getting the remote JavaScript code and evaluating it under my process, I have basically like, React Lazy or Next Dynamic. And I've got a special function in there that uses fetch, and it actually posts out, and we have a Webpack plugin that creates a renderer on the other side. So I can tell the remote what I want to render, and it returns back the CSS chunks, the JS chunks, and the HTML. And then we can reconnect it to the current DOM tree. So any children inside of that remote that you just server-side rendered can still participate in React context of your host's tree. So I'm not having to completely run it in isolation, but I can server-side render the wrapper. And if I was passing any children in, I can reattach those children back to React context so they can continue to dispatch actions or do anything like that. And yeah, so I mean, it's really ugly, but pretty much this is just a really dirty example. So these are two, these are two Next.js apps pretty much, where this is test page, and then I have test 1, 2, 3, 4. So let's see, provide. So I have consume federated module. I'm just jumping in here quickly to find where I actually do it. And so it's really quick and dirty, but pretty much I've got my component that I'm going to get, which is sample component from provided remote. And then I'm going to just pretty much, I don't even use the children, but I could use the children and it would read them out. But this component just returns testing 1, 2, 3, 4. So if I go over here, and there's still a bug I need to fix in mini CSS to get rid of the flicker or the hydration warning. But if I go and view my page source here, let's see, where is view page source? Why am I not seeing it?
I think it's down. You
Okay.
have tools. Yeah.
Services, where is it? For some reason, my view source is not. Oh, it's because I have text highlighted. Sorry. Okay, view page source. So if I go in here and look at the server-side render, and then I go, I should see it pop up. Come on now. Okay. And there we go. Testing 1, 2, 3, 4. So that H1 came from this service over here. So if I jump into here, you go to the components, there's sample component H1. Oh, I'm not even using that sample component. I must be using it from some other place or passing different context into it. But pretty much the idea is that I'm able to server-side render code that originally isn't part of the initial page load. And I'm able to pull in this code over the network. And so what we do is we kind of create this renderer layer, which we built a plugin for. And then we use a federated component over here. We call it federated component. And pretty much inside of here, this is where we do all the fancy magic. So I can go into we pretty much have a parser, so I can parse the node definitions. I use this parser. I get the server-side render. I find the children. We put these invisible markers around the children. I can get those children, process the node, and then reconnect the node as a React fragment. And that's how we reattach any of the children that you would have passed into the server-side render. We can reattach them to the context tree. But this is just like a really basic, rough example of showing how to do server-side rendering, where you can actually just go out to the network, kind of like how Akamai, or not Akamai, how edge side includes would work, where you could reach out and have these ESI tags, except all of this stuff can still participate in the React context tree. So it's quite handy. Like if you think about putting this on the edge nodes, you could deploy, say, your Meganav to an edge worker or a Cloudflare worker, and you could just use fetch to go out and get the server-side rendered header and load it into your site. And then once it gets to the client side, federation kicks in and continues making it interactive.
Awesome, good stuff. Thank you so much. It's definitely an added treat to have you on the panel, so thank you. I did think about trying to reach out to you before, but I couldn't find you online. Something about my Googling skills. Okay, when should I use loadable instead of module federation?
What do you mean for loadable?
Do you want to enlarge on that, Dean?
Like loadable components, like React loadable or React async component.
Yeah, maybe you want to just add a bit of context around that, Dean, if that's okay. Is he React loadable?
Okay, so yeah, so a little context to what the React loadable is for anyone who doesn't know is when you code split an application, basically server side, you need to be able to get those chunks synchronously. And you also need to be able to do what we call a chunk flush. So when I run the server bundle, I need to map all of the async split points and end up getting the CSS and the JS that correlates to them on the client side. So I can render out the tags so that the page loads and it's not just, I put the main bundle on the page and then Webpack kicks in and, dumps a whole bunch of other scripts and tags on the page. So when you use loadable over federation, pretty much I would use loadable when it's an internal code split. So when you're code splitting your internal application, and then really use federation when you're not using React loadable. The reason is because we have not patched React. We haven't patched loadable or any of the libraries with chunk flushing mechanisms, so that they can reach out and actually flush out the CSS and JS chunks. So the extractor will fail if you try and put React loadable around a federated module. So this is kind of this fetch example that I showed you that's hooked up to Next.js. It includes that. So Next Dynamic has all of that, and then we created a chunk extraction layer so that all the CSS and JS get server-side rendered out, and we can do the correlations and all of that. But that's when you should use them and shouldn't, is if it's federated, don't wrap it in React loadable, because the dynamic import will get transformed by Babel, and it's going to get transformed into something the server isn't aware of. And so you kind of want to leave those imports alone and let them just run naturally, or use a top level await if you need to get it to work server-side or something like that.
Brilliant, thank you. We are at time now, so if people do want to drop off and have their teas and whatnot, which we do in the UK, please feel free to do so. Those who want to hang around with Luca and Zack for another 10-15 minutes or so, please do hang around as we carry on going through some of these questions, if that's all right. Are you two okay for time, Zack, Luca?
On my side, I'm fine. Zack didn't know about that, but I'm glad you are here, mate.
Great.
Happy to be here.
So Alan's asked, you already said a little, but do you think using PubSub or local storage for micro front ends is more reliable channel than using store context such as Redux or Vuex?
Personally, I think it's the way that you can decouple your system. It doesn't mean that you don't have to use Redux or Vuex. Inside your micro-frontend, you do whatever you want. But the communication that is going outside has to be, in my opinion, completely decoupled, because that will allow you to independence between micro-frontends. That is basically what you are optimizing for. Often, you know, it's you end up in distributed system when you have a lot of external dependency towards the hell of the distributed monolith that is an anti-pattern in that world. And it's definitely something that you don't want to find yourself, because otherwise you're going to regret. You never know how the things are going to evolve. Therefore, if you can maintain strong boundaries between micro-frontends, that's for me the way to go.
Cool.
Yeah, so I'm very pro the single render tree setup, just because of the convenience of it. So I kind of think of, you have micro front ends, and then we kind of have something new flavor that's cooking up, which I kind of just call it a federated application. So it's more, it has like slightly more bounded context, but you get the benefits of like that monolithic style app or like a polyolithic app. What I would say is, yeah, I would, if you want to keep separation of concerns done well, then, you know, depend on some outside storage system like local storage or event buses to communicate. Otherwise, what you need to do is make sure your apps have like a common app shell, or something that we do is we have like a high order component that's called with global data providers. So anything that a server would need to spit out for any of the other apps to run, or any like global context that everybody would need, we put it into that, which is kind of like, you know, if we were to have local storage. The app shell is controlled by, say, a platform team, and anything that needs to be globalized is put in there. Otherwise, everything else remains localized. And if you do go with that single render tree approach, really what comes into focus is you need to have very strong foundational design patterns. So I would often start out with keeping them less coupled until you have a good reason to have them coupled, just because it's going to reduce that overhead, especially looking at new technologies.
Awesome. Alan Shio asked, you already said a little, sorry, I've already asked that one. Almos asks, any suggestions for dissecting an existing monolithic deeply coupled server-side rendered app and for moving to a micro front ends architecture? What would your main considerations be going into a big task like this? And then also John Parsons is saying, is that usually only in an enterprise scenario, or would you be, what's the ideal team size that actually this starts making sense?
I have seen, so let's start with the second one that is quick to answer. Probably Zack can share his experience. My experience, what I have done in the last 2 years is talking with a lot of companies to understand how they are building micro-frontends and trying to identify patterns. I have seen 2 or 3 use cases that micro-frontends can shine. One is definitely when you have a large organization with distributed teams, that is, let's say, I think is a given. But the another one that was quite interesting is with multi-tenant applications. Therefore, if you have a multi-tenant system that you need to tweak, so maybe you have a small team, but you want to have this encapsulation that is very strong between different customers, and you want to tweak maybe some areas for one customer and some others for another one, you can have a base set of micro-frontends that is your common part, like sign in, sign up, that's very unlikely that is going to change too much. But inside the authenticated area, maybe you can have modules and other stuff that are going on and change customer by customer. And multi-tenant became a very interesting approach for micro-frontends despite the size of the team. That's for the second one. I don't know what is your experience, Zack, if you have any other use case where you see micro-frontends shine.
I would say the most interesting one, I can't name names, but the most interesting one I've seen is that there are car companies out there who are using Federation to actually drive the UIs inside of the more modern cars. So those are cases where, yeah, okay, they could be big enterprise companies and so on and so forth, but also whoever controls the microcontrollers of each component of the vehicle is usually extremely distributed. And so the pattern works really well there. But generally, like where I use them or see them and have used them the most is to manage scale issues. So dealing with, I think the biggest one I had was 150 separate micro front ends that we had to manage. And mostly like that's where they start to come into focus, is like when the organization, when your architecture starts to crush the organization and you need that agility, that autonomy, and that speed. And that's really where I start to factor them in. But yeah, they can definitely be used for, like you said, on multi-tenant applications. I think that's another good one. But generally, the only place I've ever put them into play is when I need autonomy or when I need more speed or when the organization itself is too large to be bottlenecked by one build pipeline.
Yeah, that's great. And by using Federation with micro front ends, do you get rid of some of the dependency on this like Uber mono repo bootstrap that you end up having, like this, you know, almost sometimes the bootstrap can become a monolith in itself, and so can using Federation help with that?
Yeah. So like I think a good example is like how we used to do them before Federation came around was you'd have like a Minikube. So you'd point like 50% or 80% of your things in Minikube to your online servers, and then you'd run the one micro front end that you need locally. Where this Federation, you can just point the script tags to wherever they need to come from. And also someone had mentioned like strangling out a monolith or a big monolithic application. The same pattern there, you could pretty much have your monolith post whatever data it needs to a React layer, and the React layer respond with the JavaScript and the CSS chunks. Your monolith take that, put it the head, the foot, and then put the content in there. And then Federation kicks in on the front end, and you kind of either suppress the hydration warning and just have it rehydrate itself with a federated code. Yeah, I think I got off topic there.
No, it's great. It's really good stuff. And I guess I'll ask one last question before we wrap up, because I think we're a bit at time. But how do you tackle the dev issue that developers might develop against one version? So I guess you're just talking about version control in general, and users might get another. So the kind of management of your version dependencies can get a bit crazy, I would have thought, if you're doing this across enough teams, especially if they're in different departments. How do you manage that? Is there ways of doing that?
Exactly, you have the experience in your company, I guess, on this one.
Sure. Pretty much like there's a couple ways to go about doing it. The main method that we've seen, and it's not really that different from how kind of you would manage it prior, but essentially when you deploy your code, firstly, you should make sure your remotes are named something. So I usually put the version of the remote onto it. So I'll make the remote name, remote _010 or something like that. And then with the key that you give in federation for a remote, the key of say nav can have a value of nav _010. So I'm still importing nav/whatever inside of whatever the consumer is, but I'm directing it to a different object on the window. So that lets me be able to actually version it out and have multiple versions of the same remote on the same page. And how you kind of can control that is either, put a query string on the end of like, you could have whatever.com/remote entry query string v equals whatever, and you have an ingress just bounce you to a certain CDN directory or something like that. Otherwise, you can just deploy it flat to the CDN and just run a little job to rename the name of the file to something like to have the version with it as well. So you could get remote entry.v101.js. And that's kind of how I've managed it. And then like I've built a UI so that, or you can do this with say like with a couple things, but some feature flag thing or something like that. But basically a UI where you can switch the versions on the fly if you need to. And then
I think
another good option is
the question is also around shared libraries. So like if I want to handle React, I have a team is working React 17 and React 18 is coming out and another team is trying that. I think that is the part is,
okay. So that one is, especially with singletons, it gets a lot trickier. What I would suggest is share scope. You can put things into two different share scopes. So I can say, hey, here's React, and I can import it as something else. So I could alias it in Webpack and call it new React and old React. And I could just go and import new React from wherever, and I can kind of share them on different share scopes. So you could create a legacy share scope and another one so they don't conflict with each other, even though they're singletons. And then you could kind of have them, like I've never tried it through the share scope entirely, but if you go to module federation examples, you'll see I have one that's called different React version. And literally I've got like React pre-hooks and React post-hooks, and I have a React hooks component loading inside of a host that doesn't support React hooks. And I go and type into an input and it's setting state via a hook into the old legacy host. So it is possible to do. It's just like, it can get a little clunky. And again, comes down to like, what's the implementation detail that you're going to use for it. But it is definitely possible. It's just with singletons, there are some extra considerations you have to take into account. Like if you have two different major versions of Angular and you expect them to run in a single DOM tree, that's going to be a problem. If you did micro-frontends where you mounted them all in a DOM node, you're not going to have any issues because you're not putting things into another render tree. But you're saying, okay, well, here's the sidebar, mount to the sidebar. Here's the menu, mount to the menu. They can be whatever React versions they want. And the sharing mechanism underneath is just going to share whenever possible based on the versions that are available for it to run with.
Brilliant. Absolutely fantastic stuff. I'm totally going to go and have a good play with this over the weekend. So thank you very much for your wonderful talk and excellent thoughts, Zack. So we will wrap up there for today. The video will be shared. Please do come along next month also and submit your suggestions. Thank you very much. Thank you.
Thanks.
Thanks for letting me join.
Thank you.
Thanks, Zack.